Right, thank you very much. Boys and girls and colleagues, good morning. Today we are going to look at analytical geometry. Mostly that will be grade 10 and grade 11 revision. Of course, that is the work that we did in grade 10 as well as grade 11. Of course, since now we are preparing for the final paper, you have seen how you have performed now in this trial examination that you wrote. I think it's very important now. This is one of those topics that you must make sure that you collect as much as possible. Please pay attention throughout these sessions. If you have questions, please ask those questions so that we can get the clarity. It's very important, and I believe that if you send those questions through this presentation, I think the second quarter now of this presentation, then I'll be able not to respond to your questions. Right now, let us start, boys and girls. Of course, we know analytical geometry, right? We know analytical geometry. It takes plus or minus 40 marks. Now, out of this 40, if you can just make sure that you run about plus or minus 30, then I think you'll be on a good side. Right, what is it that we must look at on this one? Of course, we need to remind ourselves about the tools that we need before we can solve the analytical geometry, which is very, very important. Of course, when you look at this one now, we have the revision from grade 10, of course, as well as grade 11. And now you remember now, most of the time here, we will be having the distance between the 2 points. Of course, you remember the distance, the formula that you use when you determine the distance between any 2 points, or the length of the line segment AB. The line segment AB. Of course, now we are going to have, this is the formula that we use. AB is equals to the square root of x squared minus x1 all squared plus y2 minus y1 all squared. You see, it is very important now to familiarize yourself with what? With the formula sheet. It's very, very important, right? Of course, on top of this one as well, I can also add the one of, say, now AB squared now is equals to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now everything then must be inside the square root. No, everything now must not be inside the square root here because we have 2 on this side. Now, why am I adding this formula now? Remember now, under this the distance formula, now you'll find that we have 2 possible questions. You have 2 possible questions that you can get on this. So the first one, of course, they can ask you to determine the length between 2 points A and B. Right, and then the other one, you'll find that the distance will be given, right? The distance will be given, and the only thing that you can do there is to find the value of x or the value of y. Of course, the first formula is still relevant, but now most of the time I've realized that most of the learners, once they have the square root, it's not easy for them to get rid of that square root. Of course, that is why now I encourage some of you now to go through this way, where you have AB squared, you just substitute the length of AB, and now you substitute x2 as well as minus x1, then y2 minus y1. Right, of course, that is for the distance, the length between the 2 points A and B. Of course, the next thing that you must look at as well is, now you must make sure that you have the coordinates of A as well as the coordinates of what? As well as the coordinates of B. Right, now I think now that is the first thing that you must look at. And now the second one, of course, it will be what? It will be the gradient, right? You still remember the gradient formula? Yes, we still remember the gradient formula. MAB equals to y2 minus y1 divided by x2 minus x1. It's very important, this one. But most of the time, I would really like to add this one to say, what do I need for me to determine the gradient formula? Of course, I must have what? I must have the 2 points. I need to know the coordinates of A, and also I need to know the coordinates of what? The coordinates of B. But you'll agree with me, in some situations you find that you have only 1 point. In that situation, what is it that you must do? Then, of course, later on, you look at that one to say, okay, if I have only 1 point, then it means for me to have the gradient, then there is something that I need that will enable me, that will help me to have the second gradient. Good. Now the third one, of course, it will be the coordinates of the midpoint of the line segment AB. I believe that you still remember the formula there. Here's the formula. that is m there into x1 plus x2, then we divide everything by 2, then y1 plus y2, then divide everything by 2. Of course, also on this one, the question can be asked in two ways. Then they can give you the midpoint as well, and then they ask you to determine what? To determine the coordinates or the point x or y. Right. Now the last one, of course, it will be the standard form of the equation of a straight line, which is y is equals to mx plus c. Or you remember that if you don't use this one, of course, you can take the second one, where you have y minus where 1 is equals to m into x minus x1. Of course, most of the time when you use this one, you remember now you must have a point on that line as well as what? As well as the gradient. It's very important. M stands for our gradient. You remember earlier on you talked of the gradient, and of course now x1 and y1, you need to have a point on that line. Right. Now, we are saying now we also have what? The collinear points. Remember now, these are the points that lie on the same line. These are the points that lie on the same line. Right. What do you know about the collinear points? Of course, they have the same gradient. Remember now, I'm referring to this line here. I'm referring to the line. If this is A, this is B, and this is C, then we agree that now the gradient of AB is equals to the gradient of BC. The gradient of AB is equals to the gradient of BC is equals to the gradient of AC. It's very, very important. Then, of course, you'll just look at the given information, then you choose. It's either you take the gradient of AB is equals to the gradient of AC, or you take the gradient of AB is equals to the gradient of BC. This will just depend on the type of the questions that you have, right? Boys and girls, like I said, it's very important when you get to the distance, when you get to the gradient, the midpoint, of course, the equation of the straight line is straightforward one. You need to remember that these questions can be asked in more than one way. Then when you practice this one, make sure that you check both ways, because if you only concentrate on the distance, now if the distance is given, what is it that you're going to do? Right? And the last one that we can also add under the angle of under the gradient there, that will be the angle of inclinations. Remember now, it's still under the gradient here, where tan theta here is equals to what? Is equals to m. Of course, I'm happy also to write this one here, because you will see that sometimes on some of the questions you get that the angle is given. You find that the angle is given, and now the question then asks you to determine the gradient. Now you remember, for you to determine the angle, you need the gradient. And also you can do the same thing here. If the angle is given, then you can use the angle to determine the gradient. I think boys and girls will agree with me. It is very important each and every time to make sure that before you start with this, to answering the questions, make sure that you just give yourself a short summary about the analytical geometry. What is it that you need? What are the tools that you need to solve this type of questions? Right. Now, let us take these questions quickly to see what is it that we need on this one here. Right. We have question 4. This, of course, was February 2011. They are saying here in the diagram below, triangle PQR with the vertices P and Q as well as R is given. Then we can see there that is P. What are the coordinates of P there? That is -1 and 2. The coordinates of R you can see 3, 0, and Q there -2 as well as -2. Right, now let us look at the first question. What is the first question there? The first question says now we must calculate the angle that PQ makes with the positive x-axis. The first question says calculate the angle that PQ makes with the positive x-axis. Right, now, if they talks of the angle, what comes in your mind? If they talks of the angle, what comes in your mind? Of course, you will remember that for you to have the angle, you need the gradient. That's what I said earlier on. For you to have the angle, you need the gradient. Remember now, the angle that we are referring here, it must be with the positive x-axis. Now, here is PQ. Then the angle that we are referring to now, it's this angle here. we want to find the size of this angle that PQ makes. Of course, now it means first of all, now we need to have what? We need to have the gradient of what? We need to have the gradient of PQ. Now, what is the gradient of PQ there? That is, of course, y2 minus y1 over x2 minus x1 over x2 minus x1. Good. Now, we need to check now. Then it means we are going to use P as well as what? As well as Q. We are going to use P as well as Q. Right, from this one, I can say this is x1, y1, x1, y1, and then x2, y2. x1, y1, and x2, y2. Right, of course, from this one now, I can now say, okay, y2, there is a minus 2 there, minus 2, that will be what? That will be x1, y1, divided by x2 there, it's also minus 2, and then x1, there is a negative 1. It is negative 1. Now you must put it inside the brackets so that you can now be able to multiply by the negative sign. Right. The next step here will be what? We just simplify negative 2 minus 2. That will be minus 4. Now minus 2 minus 1. When you multiply the 2, now they becomes what? Positive. Nay, negative times negative is a positive 1. Now minus 2 plus 1, of course, that will be minus 1. Then what is the answer here? You see that the answer here now is what? The answer here is, it is a positive form. Right, now, remember now, most of you will say now that what if now I decide to say this is x2, y2? Of course, it doesn't matter. What is important is make sure that if you say this is x2 and also this one must also be what? This one must also be y2, then this will be x1 and the other one will be y1. It is very important. Right, now we have what? Now we have the gradient. Now, which formula now do we use when we determine the angle of inclinations or the angle that PQ makes with the positive x-axis? Of course, now we will see now a tan of theta, if we name that angle to be theta there, tan of theta then is equals to what? Is equals to m, right? Tan of theta there is equals to m. Of course, what is our m there? M there is what? Is 4. Then from here now, you remember now, you just multiply both sides by the inverse of tan, or the tan arc is very important. Therefore, we have the inverse of tan 4 there. Now, the answer there is what? What is the answer on this one? Of course, you can use your calculator on this one. Then we have the inverse of tan positive 4. Then our answer there is 75,96 degrees. Then the answer there is 75,96 degrees. Of course, it's very important. The gradient is positive. If the gradient is positive, it means we are expecting to get the angle which is what? Which is less than 90. Expecting to get the angle which is less than 90. Of course, that is the first question there. Right, boys and girls, like I said earlier on, it's very important to make sure that we are able to use the two. Right, it is very important to make sure that you're able to use the two. Now, if I say to you now, this angle now, it is given. If I say to you now, this angle here, it is given now, they are saying this angle here, it is what? The angle here is 75,96. And of course, the coordinates of P on this side, the coordinates of Q, then it's a minus 2 as well as P. And of course, this one is still minus 1 as well as 2. Right, now you are asked now to determine what? You are asked now to determine the gradient of PQ. You are asked now to determine the gradient of PQ. What is it that you are going to do here? Remember, for you to determine the gradient, you must make sure that you have the 2 points. Of course, when I look at this one, I have P as well as Q. But the problem here is I cannot use the gradient formula. Why? Because I don't know what is the value of what? What is the value of P? Therefore, I cannot use the gradient formula. Then I must look for another way. Right, now, what is it that I have also here? Now, immediately once you see that you have this angle which is 75,96, that is our angle of inclinations. Therefore, we can use the angle now because we know that tan of theta is equals to m. Right, now, we have the angle which is what? Which is 75,96. 96. Then we can now use this one. It's just substitute the angle there. And now immediately from this one, you just say, okay, what is tan of what? What is tan of 75,96? Now the answer then you can see now that is 3,98888. Of course, that is 3,9988857. This is our m. Now, when you round it off to 2 decimal places, now you'll see now the gradient is equals to 4. Then, of course, I believed that the next question immediately once we have this form, the next question will then be determining the value of what? Determining the value of p. Then, of course, since now you have the gradient, now you can use the gradient formula now to determine the value of p. It's very important. That is why I said earlier on, make sure that you are able to use the two to be able to determine the gradient, and also to use the gradient as well as to find the angle of the inclinations. Right. Now let us look at 4.2. 4.2 there, it says now you must determine the coordinates of m. What is m? M is the midpoint of what? M is the midpoint of PR. M is the midpoint of PR there. That is a 2 marks question. Boys and girls, I believe now you are familiar with this type of questions. Of course, it's a 2 marks questions. Yeah, maybe 2 minutes we will do on this one, right? Can you determine for me the coordinates of M, which is the midpoint of PR? Then immediately after 2 minutes, then we'll talk about what strictly 2 minutes, boys and girls. We must learn now to use our time effectively. Right, thank you, boys and girls. Your time is up now. Let us see what is it that we have, right? Can you see? You can just check your answer there with your colleagues next to you there. What is your answer? Yes. Now, can you see that one is correct? Yes. Now, let us now check. I can see now there are those who make some of the mistakes there which are not important, boys and girls. Please let us make sure that each and every time when you work out this one, you work it out in a correct way. What is the formula first? It's very important now. The midpoint there is m into x1 plus x2 divided by what? Divided by 2 there. And now we have y1 plus y2 divided by what? Divided by 2. Of course, now from here, now you can now do your substitution now. They said the coordinates of M, which is the midpoint of PR. Now it means now we need to go back to our diagram now to check where is PR. This is PR. Then it means M is somewhere on this side here. Right? It means now we needed the coordinates of R as well as the coordinates of what? As well as the coordinates of P as well. Right, now from here now we will be saying now, okay, x1 here is what? X1 here is a minus 1, and then what is x2? Then x2 of course will be this one here where we have a plus 3, then we divided by 2, and now we have y1. What is y1? Y1 of course it's 2, and now what is y2? Y2 there you can see it's 0. Then we divide it by what? We divide it by 2. Then you are right there. Now from here now we can simplify now to say, then we have minus 1 plus 3. What is minus 1 plus 3? Minus 1 plus 3 is 2. Is that correct? Yes. That is 2 divided by 2. And then 2 plus 0, of course, is 2. We divided by 2 as well. Therefore, now the midpoint here is 2 divided by 2, the answer is 1, and also 2 divided by 2, then the answer is 1. Then you can see now the midpoint of this line is where x is 1 and also where y is a positive 1. Right, of course, boys and girls, you can see now your answer there, it's 100% correct. Yes. Now, let us now move to the next question. It says now, you must determine the perimeter of triangle PQR to the nearest whole number. determine the perimeter of triangle PQR to the nearest whole number. Of course, boys and girls, when you talk of the perimeter, you still remember that you are talking about what? You are talking about the distance around the distance around the shape. Of course, now, what is it that we need? Immediately when you say the distance around the shape, it means now we need to use the distance formula. It means we must have the distance of what? The distance of PQ and the distance of QR as well as the distance of PR, right? Yes, we must have the three distance around this because this is a what? This is a triangle, right? Now, boys and girls, it's a 5 minutes question, of course. Please, 5 minutes, then I'm going to give it 4 minutes. Now, I'm going to give it 4 minutes. Then immediately after 4 minutes, then we are going to discuss this one. Make sure that you familiarize yourself with these questions, boys and girls. It's very, very important. Right, thank you, boys and girls. Thank you. I believe now you are done with the question. Of course, determine the perimeter of triangle PQR to the nearest whole number. Right, now let us see now. It means now, first now, since you are going to use the distance formula, we can start now with what? We can start now with PQ. No, we can start now with PQ. Then you can see now PQ there. It's a what? PQ. It's a minus 2. Why minus 2? You will remember now that is PQ, x2 minus x1 and y2 minus y1, right? Of course, now we are going to have minus 2 there as well as what? Minus 2 as well as minus 1. Of course, let me write it here so that you can be able to see now minus 1 and 2 there. And Q, coordinates of Q, that will be minus 2 as well as minus 2, right? I think in this way it will be easier for us to see now. If we say this one now, it is x2 and y2, and this is x1 and y1, right? Now, we have minus 2 minus 1, right? And then we must square it plus y2 there. Y2 is a minus 2, and then y1 is a positive 2. Therefore, it's going to be what? It's going to be a minus 2, right? Now, when you simplify this one, it is a minus 2 minus 1. Well, first you multiply 2. Negative times negative is a positive. Now, minus 2 plus 1 is a negative 1. Therefore, we have a negative 1 squared there. The same apply on this side. Minus 2 is a negative 4. Right, of course, negative 1 squared is a positive 1, and now negative 4 squared is a positive 16. Right, when you add the 2, now you get the square root of 17, which is more or less 4 comma what? 4 comma 1. Right, now, what about PR? PR as well. The coordinates of PR there, remember P is a minus 1 and 2, and then the coordinates of R will then be what? The coordinates of R will then be, will then be 3 as well as 0. Right, and now we have x2, y2, and we also have y1, x1 and y1. We also have x1 as well as y1. Then we have 3 minus 1. Of course, it's correct. We square it. And now plus 0 minus 2. Then from here now you can see now 3 minus 1. This now is going to be positive 1. Then 3 plus 1 is 4. And 0 minus 2, that will be minus 2 squared. Of course, now we are going to have what? We are going to have 4 squared is 16. Minus 2 squared is 4. Now when I add the 2, they give me 20. Now when I round it off to one decimal place, then it's give me 4,5. Right? That is, of course, the distance of PR. Then now we have QR. Now the coordinates of Q, you said it's a minus 2 and minus 2. And now the coordinates of R, 3 as well as 0. Right, now from here now you can see this is x2, this is y2, and also this one is x1 and y1. Then you are going to have minus 2 minus 3 there as x1, and we have minus 2 and minus 0 there as our y1. Of course, when I simplify the 2 there, it is minus 5 all squared plus, then you have minus 2 all squared. Then the answer there, minus 5 squared is 25, and minus 2 squared is 4. Please, this negative 1, make sure that you put it inside the brackets, because if you only say minus 2 all squared, it will give you the negative 4, which is not correct. Then 25 plus 4 is equals to 29. Therefore, the square root of 29 there is a 5,4. Right now, we must answer the question now. What does the question say? The perimeter, that is the distance around the shape. Therefore, now we can now say the perimeter here, the perimeter is equals to the square root of 17 plus the square root of 20 plus the square root of 29. Now we add the 3, we check what is the answer there. The square root of 17, then plus the square root of 20, then plus the square root of 29. Then the answer there we can see now, they said you must round it off to the nearest whole number. Therefore, this one is going to be 14 units. That is the distance now. That would be 14 units. Okay, right. Boys and girls, now I believe now you understand this one now. The perimeter, that is the distance around the shape. Therefore, you must just add that one. Also remember the formula that we have learned now in grade 9 as well as grade 10. Right, now, boys and girls, now let us now look at the last question here in this paper. That is question 4.4. Determine an equation of a line parallel to PQ that passes through M. Determine an equation of the line parallel to PQ that passes through M. Of course, this one will say now, you remember now, the equation of a straight line is y is equals to mx plus c, or one can say now y minus y1 is equals to m into x minus x1. Right, now, what are we going to do now? Of course, you must ask yourself, to say now, if I want to determine the equation of a straight line, what is it that I need here? We agree that this is the gradient, right? This is the gradient, this is the y-intercept, or y value on that line, or you need a point, you need a point on that line. The same apply, it is the gradient, and also to have x1 as well as y1. These two now you must have a point on that line. It is very important. Of course, now let us look at this one. They said you must determine the equation of the line parallel to PQ, and that line passes through M. Then here it's our M. You still remember what are the coordinates of M? Yes, the coordinates of M then was 1 and 1. That was the midpoint. That was our midpoint of PR. Right. Boys and girls, now how do we determine the equation now? Now, this is very important now. We are told now this line is parallel to PQ. It's very important. Remember, I've mentioned to say, always remember now, for you to have the gradient, you must have the 2 points. For you to have the gradient, you must have the 2 points. But in case where you have 1 point, then you must check the following. They will mention to you to say, this line is parallel. And also, if they don't say parallel, they will say it is perpendicular. Right? Now, to determine the gradient of the parallel line as well as the perpendicular line, what is it that you need now? You remember for parallel line, they have the same gradient. Now here we say M1 is equals to M2. If you are told that lines are parallel, now you must remember that they have the same gradient. They have the same gradient. Now the same applies with what? With the perpendicular lines. If you are told that lines are perpendicular, then it means M1 multiplied by M2 is equals to a -1. Therefore, now this will enable you now to have what? To have the gradient of that line that you want to find the equation of, right? Good. Now, let us look at this one now. We have the gradient of PQ. What is the gradient of PQ? The gradient of PQ, you said is equals to what? Is equals to 4. Right, you said the gradient of PQ is equals to 4. Now, it means the gradient of PQ is equals to 4 is equals to then the gradient of what? Of the second line there, which passes through what? Which passes through M. Then now we can now say y minus y1 there is equals to M into x minus x1. Now you substitute the gradient, which is 4. Good. And then from here, x minus. Now you take x1 from here. That will be x1, y1 minus 1, and y minus 1 on this side. Now we have 4x minus 4. We take 1 on the other side. It is plus 1. Therefore, y is a 4x minus. Y is 4x minus 3. Y is 4x minus 3. Okay, thank you very much. Now, boys and girls, remember now, this is very, very important. The same apply. If they said it's perpendicular, then you remember now, okay, that is 4 multiplied by M2 is equals to negative 1. You just divided the 2 by 4. Therefore, M2 then will be negative 1 over 4. Right, boys and girls, I tried on this first session to make sure that you really understand how to use your formula and make sure that you interpret questions correctly. Right, now, before we take the break, I think which will be in 4 minutes time from now, let us quickly look at this question. Before we take the break, let us quickly look at this question. Boys and girls, now it's very important to read the instruction name. Very, very important. ABC is a triangle with the vertices A, B. I'm interested at B. What are the coordinates of B there? It's 2 as well as 0. And C, it's a P and minus 4. With P being greater than what? 0. Then in the Cartesian plane, AB makes an angle of 45. With the positive x-axis, immediately I see this one. What comes in your mind? Of course, that is the angle of what? That is the angle of inclination. It's very, very important. Now, the last part is AC is the square root of 50. What is this one? Of course, it's not a gradient, it's not a midpoint, but it's a what? It is a distance. Then the distance between AC is a square root of what? Is a square root of 50, right? Boys and girls, now you can see now in this diagram, in this case here, we have A, we have B, we have C. Then everything now it has been represented correctly. What is the first question? I think it's a 2 marks. I think this is the question that will lead us to the break. Okay, the first question says, determine the gradient of AB. Determine the gradient of AB. How do you determine the gradient of AB? You must have the 2 points, A and B. Good, is that correct? Yes. Now, here are the coordinates of A. Are you happy with the coordinates of A? Yes, I can see that A, the coordinates is 1 as well as what? 1 as well as 3. And now, what about B? Then B, are you also happy with B? No, I can see you are not happy. I can see you are not happy. What is the reason? Yes, you don't know what is the value of T, right? You don't know what is the value of T. Therefore, it means we cannot do what? We cannot use what? We cannot use the gradient formula to determine the gradient of AB, right? We cannot use the gradient formula, right? If you are not going to use the gradient formula here, what is it that you are going to do then? We are not going to use the gradient formula. What is it that you are going to use? Then, of course, we must look. We don't have the parallel line. We don't have the perpendicular line. Then the only thing that we have is this angles here that AB makes with the positive x-axis. Now, what is this one here? That is our angle of inclination. Of course, now you remember now when you calculate this angle, you say tan theta is equals to M, right? Yes. Now, what is this M stand for? For the gradient. And this one here, of course, that is the angle that the line makes with the positive x-axis. Right. Now, let us now substitute here now to say we have the angle which is what? 45 degrees is equals to M. Then from here now, boys and girls, now look at this one. You're going to smile when we get to the answer here. Right, the answer here, that is tan of 45 degrees. What is tan of 45 degrees? Then it's 1. What is the meaning of this? What is the meaning of this? It means the gradient of AB. It means the gradient of AB the gradient of AB is equals to 1. It means the gradient of AB there is equals to 1. Of course, boys and girls, remember now, if, like we said earlier on, if you see that I don't really get this one right, remember you can just ask that question so that at least now in the next session now you can be able to respond to those questions. Right now, I think after break, we'll be looking at 4.2, which is also very interesting now because they said now we must calculate the value of t as well as 4.3. Boys and girls, now we're going to have the 5 minutes break, 10 minutes break now. Immediately after this now, we are going to continue. Thank you very much. Thank you very much, boys and girls. Welcome back. Remember now we're busy with the first question there where you were supposed to calculate the gradient of AB. And now we couldn't use the gradient formula there because we don't know what is the value of t there. Now we had to use the angle of inclination, which is 45. That is where we ended up saying now the gradient of what? The gradient of AB there is a positive 1. Right, let us now go to 4.2. Let us now go to 4.2. 4.2 says now you must calculate the value of t. You must calculate the value of t. Now you can see here it is t. T is on the line AB. Is that correct? T is on the line AB and also is also on the line BC. But now, we cannot use BC. Do we have something on BC? No, we don't have extra information on BC. But with AB, we have the gradient of AB. We have the gradient of AB. Therefore, now we can use that the gradient formula, right? Yes, you agree that we can use the gradient formula. I believe that, boys and girls, because this is a 2 marks questions, I think you already have the answer now. Yes, I can just see the smile that you have that answer. Let us see if your answer is correct. Now, the gradient formula is the y2 minus y1 over x2 minus x1. Right now, from here now, you only substitute now. What is it that you're going to substitute here? You set the gradient is equals to 1. Therefore, 1 is equals to y2. Y2, of course, it will be from the diagram here to say this is x1, y1, this is x2, y2. Then, of course, y2 is a 3 minus 0 divided by 1 minus t, right? And, of course, from here, we can now do what? Cross multiplication. Of course, let us simplify this first. 3 minus 0 is a 3. Divided by 1 minus t, which is equals to 1. And therefore, now immediately after this now, because we have one term on the left-hand side and one term on the right-hand side of the equal sign, therefore, cross multiplication, 1 minus t there, we multiply it by 1, of course, everything will stay the same. 1 times 1 is 1, 1 times minus t there, it's a minus t. It's equals to 1 times 3, then 1 times 3 there, it's a positive 3. Now immediately from here now, what is it that you're going to do now? Immediately now we say minus t is equals to, we take 1 on the other side, that will be 3 minus 1, which is equals to what? Which is equals to 2. Therefore now we are looking for t, not a minus t. Then divide both sides by the negative side. Therefore you will see now t is equals to a negative 2. Right, boys and girls, this is the answer that we have. Of course, you can check if you are right to say, okay, this is 3. Okay, let me use the second one. This is 3 divided by 1 minus minus, that is plus 2. Therefore, that is a plus 2 there. That is 3 divided by 3, which is equals to 1. Boys and girls, each and every time when I do something, I make sure that I check if that answer is correct, if possible, because it doesn't help to just be happy to write everything down, but to realize later on that what I've written down here, it is not correct. Make sure that if possible, you just check if your solution is correct. If you can be able to prove that the left hand side is equal to the right hand side, then everything then will be correct. Okay, right now 4.3. 4.3, boys and girls, you must calculate P, the x-coordinate of point C. The x-coordinate of point C. That is a 4 marks question. Boys and girls, I'm going to give it 4 minutes. I'm going to give it 4 minutes. You calculate P, the x-coordinate of C. I just want to check which approach are you going to take to calculate the value of P. Thank you, boys and girls. Your time is up now. Let us look at 4.3. Let's look at 4.3. I will go back to the statement. Remember the questions, calculate P, the x-coordinate of point C. I'll go back to the statement. There it says now, ABC is a triangle with vertices A, B, and C with P greater than 0. It means P must be greater than 0. You can see why are we saying greater than 0? Of course, x on this side is positive. Right, and now AB makes an angle of 45 degrees with the positive x-axis. AC is equals to the square root of 50. AC is equals to the square root of 50. Right, now, you can see now we have something now with regard to this one. We know that AC is the square root of 50, right? AC square root of 50. But on this side, we don't have much information. Therefore, this side falls out. Therefore, now we'll be working on AC. What is it that we're going to do on AC? We are given the distance. Therefore, we're going to use the distance formula to determine the value of the x-coordinate of the point C. Right. What is the distance formula? Remember, you said we have AC squared is equals to then x2. AC squared is equals to x2 minus x1 all squared plus y2 minus y1 all squared. Right? And of course, immediately from here now, what I'm going to do now, I substitute now AC. What is AC there? AC is a square root of 50. Then I substitute AC now to say AC is a square root of 50. Then we square it. Now it's equals to, then we check what is x2. From this one, you can see there ax2, y2. Then of course this will be x1 and y1. Then x2 will be 1 minus what? 1 minus p. 1 minus p all squared plus, the same apply with y2. Y2 will be 3 minus 4 all squared. Right. What is the square root of 50? Of course, boys and girls, if you're struggling to get this one, you just use your calculator. The square root of 50 all squared. Then it will say now the answer there is what? The answer there is 50. Right, now, the other thing which is very important now is, what do you understand about this? I know sometimes you're in a hurry in the examination. One end up saying now the answer here is a 1 minus p squared, which is not correct. Boys and girls, the meaning of 1 minus p all squared is, it means now you have 1 minus p. You multiply itself twice. 1 minus p multiplied by 1 minus p. You multiply 1 minus p itself twice. And therefore, we have plus 3 minus 4. Of course, that will be 7. That will be 7 squared. Right, when you simplify these brackets, 1 times 1 is a 1. 1 times minus p there, it is a minus p. And minus p times 1 is a minus p. Negative p times negative p, of course, is a plus p squared. And now from here, now you can see these two are like terms. Therefore, we end up having 1 minus 2p plus p squared. Right, what about this one here? This is 40, 7 squared is 49, and now plus 49. Good. Now we still have 50 on this side, we still have 50. Right, boys and girls, now we look for the like terms. 1 plus 45, that is 50. Then we have p squared there, minus 2p, then plus 50 is equals to 50 on this side. Now immediately now, because I can see now I have p squared, now I can see now this one now is going to be what? It is, of course, the quadratic equation. Now how do I solve the quadratic equation? Of course, one side must be 0. I say 0 here, p squared minus 2p plus 50 minus 50. What is this 2 here? The answer for this 2 there is what? It's 0. 50 minus 50 is 0. Now it means now we are left with p. With this 2 here, we take a p as a common factor. We are left now with p minus 2. Is that correct? Yes, that is p minus 2. And therefore, now immediately we can now remember from here, now we can say, therefore, p is equals to 0 or p is equals to positive 2. Of course, now the answer there, the value of b will be where p is equals to 2. Why 2? Because they said now p must be greater than 0. Can you see, boys and girls? Of course, if you have used the other one where you have AC is equals to the square root of x2 minus x1 squared plus y2 minus y1 all squared, then immediately from here you can now say that is 50 is equals to the square root of 1 minus p all squared plus 3 minus 4 all squared. Now the next step from here, then of course you will have to do what? You will have to square both sides so that you can have what? No, that is the square root of 50. You can have 50 here is equals to 1 minus p all squared plus 3 minus 4 all squared. It means now you don't have that square root on the other side. Right, thank you, boys, because that was question 4.4. I believe that you got that question right. Now, the last question 4.5, determine an equation of a line parallel to AB passing through point C. Determine the equation of the line parallel to AB passing through point C. Of course, now because we are determining the equation of a line which is parallel to AB, and it passed through point C. This tells you that for that line, on that line that you are finding the equation, we have only one point. Then it means we cannot be able to determine that the gradient of that line using the gradient formula. Then it means because we have only one point there, we must look for something like the perpendicular line or the parallel line. Of course, when we look at this one now, they said that line, it is parallel to AB. Now, immediately when I see the parallel, of course, I'm going to smile. Why? Because I know that if lines are parallel, they have the same gradient. They have the same gradient. Therefore, the gradient of AB is equal to the gradient of the line that passes through what? That passes through C. Now, of course, from here now, I can now say, okay, we have y minus y1 here is equals to m into x minus x1, right? What is the gradient? The gradient there is 1. You remember the gradient of AB is 1. Then from here now, you have the point C. What are the coordinates of point C there? Point C, that is a positive 2 as well as minus 4, right? Now it means x there is a minus 2 and then y there is a minus 4. Therefore, we have x minus 2. This is y plus 4, right? Now we take 4 on the other side. Y is equals to x minus 2 minus 4, which is x minus 6. Right? Then that is your answer. Right, boys and girls, of course, one will say that you're always taking this y minus y1 is equals to m into x minus x1. Of course, even if you take y is equals to mx plus c, right, we are still going to get the same answer because this is 1, and now you take 1 point on that line where x is 2, and now y is what? Y is y is minus 4. Now we are determining the value of c, that is 2, that will be minus 4 minus 2 is equals to c. Therefore, now c is a minus 6. Now, why do I avoid this one most of the time? Because you'll find that most of your colleagues there, or your friends now, you'll find that once they are here, they think now they are at the final answer. No. From here, you still have to write it in the standard form. You still have to write it in the standard form where you have y is equals to x minus what? X minus 6. It is very, please don't leave it here where c is a minus 6. The question said determine the equation of a parallel line to AB. The equation y is equals to something or x is equals to something. Boys and girls, that was November 2009. I believe now you got the question right. Now you understand you need to read the statement, the gradient, you check the angle of inclination as well, the distance you check if the distance is given. Very, very important. Right, now let us look at this one now. Question 5 November 2010. Question 5 November 2010. Yes, here we are in the diagram below. A, B, and C are the vertices of triangle. AC is extended to cut the x-axis at D. Right. Now, the first question that boys and girls is 5 points. You can see, I think in all these papers that I did, the gradient is there. The distance is there, as well as the equation. It's very important that the midpoint, of course, I need to mention the midpoint. Right, it means you must be able to determine the gradient, you must be able to determine the distance, as well as what? As well as the midpoint. Right, boys and girls, let us look at 5.1. 5.1 says, calculate the gradient of AD. Calculate the gradient of AD. Here is AD now. AD is on this line. Yes, this is AD. Right. Where do we start? Of course, we need to check first. Do we have 2 points on this? Remember, for you to determine the gradient, you need to have 2 points. Now, do you know the coordinates of A? Yes, we know the coordinates of A. Do you know the coordinates of D? No, we don't have the coordinates of D. Now, what is it that we're going to do now? Yes, I can see now some of you are pointing at C. Why are we supposed to use C? Yes, because when you look at A, C, D, these points are on the same line. These points lie on the same line. Therefore, the gradient of AC is equal to the gradient of CD, or the gradient of AC is equal to the gradient of AD. That is now we are going to say the gradient of AD here, which is the same as the gradient of AC, is equals to y2, which is 7 minus 4. Then we divide it by what? By 3 minus 3. Of course, that is a 7 minus 4 there. That is a 3. Now 3 plus 3, negative times negative is a positive. Then now the answer there will be what? Will be 6. Now then the final answer there will be a 1 over 2. That is a half. 3 divided by 6, it's a half. Right, now we have the gradient of AD, which is a 2 marks question. The next question says now, you determine the gradient of BC. Determine the gradient of BC. Where is BC? Here is BC, right? You can see the BC there. Do we know the coordinates of B? Yes, we have the coordinates of B as well as the coordinates of C. Of course, now I can now say x1, y1, and now x2, y2. Right, now 5.1.2, boys and girls, now the gradient of BC, now we have what? We have y2 there is a 4 minus 6, good, that is a 4 minus 6, we divide it by what? Minus 3 minus 1. And now the answer there, 4 negative times negative is a positive. Now 4 plus 6 is a 10. We divide it by minus 3 minus 1. Of course, that will be a minus 4. Right, from here now we can see now this will be 5, then minus 2. When you simplify it, we're going to get a minus 5 divided by what? Divided by 2, which is the same as 2,5. But I will be happy when you leave it as a fraction. Don't write it in decimal form. Right. Now, from here, boys and girls, you must also learn. Look at the line. If the line is to this direction, you know that you are going to have the positive gradient. And also, if the slope is on this direction, also, you are going to have what? The negative gradient. Each and every time when you work out the gradient, look at the line first and check the sign. Is it positive or negative? This one will help you to check your final answer. Right. Now, 5.2. 5.2 now says you must calculate now the size of DC. You must calculate now the size of DC. How do we calculate the size of DC? Here's the DC, that is DCB. Then it means we are looking at this angle here. We are looking at this angle here, that is angle DCB. Please, boys and girls, when you look at it like this one, you can think that this is 90 degrees. They did not say AD is perpendicular to what? To BC. First, make sure that you prove. If you can see down, this is perpendicular. That's when now you can say DCB is 90. But beside that one, you need to work it out to make sure that it is 90. Right. What is it that you are going to do? Boys and girls, there is a reason why they are saying we must calculate the gradient of AD as well as the gradient of what? As well as the gradient of BC. Why am I saying this one? If we can find the angle that AD makes with the positive x-axis, if we can find the gradient that the AD makes with the positive x-axis, and also find the angle that BC makes with what? With the positive x-axis. Can you see now? If we know the size of this angle here, we know now, we can now say this angle here is equals to this sum of the two. Is equals to the sum of the two. Then now we'll be able to make this one the subject of the formula. Or once we know this one, of course, we'll be able to determine this one because these are the angles on the straight line. Then from this one, we take 1 plus 2 plus 3. Now it must give us 180. That is the sum of the angle in a triangle. That is the sum of the angle in a triangle. Right now, let us look at this one. Let us find the angle that AD makes with the positive x-axis. Right. Now it means now I will call it theta here. This one I will call it what? I will call it alpha. Right. Now let me now say here we have, that is 5.2 tan theta is equals to 1/2. Tan theta there is equals to 1 divided by 2/2. Then from here, therefore, theta is the inverse of half, right? And now, what is the tan of a half? The inverse of tan half, of course, that will be 26,5. Let me look at it. That is shift tan. Of course, we have 1 divided by 2. 1 divided by 2 there. Then, of course, the answer then is 26,57. That is 26,57. Right. Now, we go now. We are happy. We know that this is 26,57. The size of this one is 26,57. We are happy about this one. Now, let us see now if we can find the other one. Let us see now if we can be able to find the other one. Now, it means you are going to use this one here. Now, we say now, tan of alpha now. Tan of alpha, we are referring to, yes, we are referring to this one now. The angle that BC makes with the positive x-axis. Now, we're saying alpha there is equals to minus 5 divided by what? Minus 5 divided by 2. Of course, now, look at the gradient. If the gradient is negative now, it means now this angle here must be more than 90. Right, of course, now, then I can now say, therefore, alpha here is equals to 180 degrees minus what? Minus the inverse of tan 5 divided by 2 there. Then we can now see this will be 180 degrees minus. Now we check to say, okay, what is the inverse of 5 tan 5 divided by 2? Then you'll see that the answer there is 61, that is 61,20. 61,20. Yes, that is 69,20. Now we minus 180 from that angle. Of course, you'll find that this one is 111,80. That is 111,80 degrees. Now it means the size of the angle here, it is what? The size of the angle here is 111,80. That is the size of the angle that we have. Right, from here, boys and girls, what is it that you're going to do now? Right, it means you have two options. Since you know that this one here is 111,80, then it means I can use the one where we say the exterior angle of a triangle is equals to the sum of two into the opposite angle. Right, now it means now I can now say what? I can now say the angle DC, alpha here is equals to theta plus what? Plus DCB, right? Alpha is equals to theta plus DCB. Therefore, now theta, what is theta? It's 111,80. Now we minus theta. What is theta there? It's 26,57, which is equals to DCB. Now, when I minus the two, 111,80 minus 26,57, then you can see now the answer there will be what? The answer there will be 85,23 degrees. That is the size of this. We can see it is very close to 90, but it is not 90 degrees. Right, boys and girls, you see, the other thing that you need to learn here, you find that some of these questions, if you solve 5.1, now before you finish this question, then you'll see that there will be another question that will need you to use whatever that you have calculated in 5.1. Right, of course, boys and girls, we are left now with a few minutes before we end up our session. Of course, now when you look at 5.3, it is a similar question like the one that we did later on. Write down the equation of a straight line AD. It will be easier for us to determine the equation here. Why? Because we can find the gradient. The gradient of AD is there. Therefore, now we can just take one of the 2 points, then we substitute it in. You have that equation. Of course, boys and girls, I believe that you have this past paper. Please make sure that you make use of this paper. Now, you work this one out. You will have the gradient, the equation of a straight line AD. Right. The same apply with 5.4. The coordinates of M. What is M? M is the midpoint of BC. Boys and girls, remember midpoint formula, that is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Of course, this one, it won't give you a problem. Right, now, I'm interested now in 5.5. If G, which is AB, is a point such that AG and M lies on the same straight line. Name, this one here is very important. Show that B is equals to 2A plus 1. Show that B is equals to 2A plus 1. Boys and girls, now it means we are referring to M, G as well as A. Right? We are referring now to M, G as well as A. What will be the approach here? Maybe if I can give you the approach then, so that at least when you work it out here, so you are not going to strike in. Right, boys and girls, the first thing that we need to work out here is to have the gradient of AM or AGM. Right? Of course, because I don't have a specific value for A as well as B, then it means I'm going to use M as well as A to find the gradient. Once you have the gradient, now you can determine the equation now in the form y is equals to mx plus C. That once you have this one, therefore now you just substitute in your y is B and now your A is X. Then you'll have that equation B is equals to 2A plus 1. Of course, this one, boys and girls, we did it earlier on, then you just go through it. Boys and girls, please just make use of these papers that you have. You know, the information that you have is very, very important, because at least now you'll get used to the way these questions have been asked in the examination. Right, of course, My wish was, I think I would wanted to do more questions with you, but because of time now, some of them I'm not going to be able to do with you these questions. But please, I believe that you have this type of questions. Make sure that you go through the questions. Right. Now, the other way of writing the equation, let us look at 5.4. C is a point such that line BC is parallel to AD. Of course, not the first time now. You know what to do when you have something like this one. Determine the equation of the line BC in the form AX plus BY plus C is equals to 0. Boys and girls, this is not the new equation. This is not the new equations. It's the equation that you know BY is equals to minus AX minus C. Or y is equals to minus a divided by b minus c divided by b. Then from here, you multiply everything by b. You are going to get this one, and now transpose everything to the left-hand side. That is where now you end up having ax plus by plus c. Boys and girls, please, I believe that you've enjoyed this session, which was very important. Remember, like I indicated earlier on, analytical geometry takes plus or minus 40. Just make sure that you go through analytical geometry and make sure that you are, especially grade 11-1. Of course, later on today, we will be looking at a grade 12. Thank you very much. I believe that you've enjoyed the sessions and continue practicing. Work hard. Make sure that at the end of the day, you pass mathematics. Thank you.